and we're really talking about when um, when values are not whole numbers. So we're not dealing with like one standard deviation from the mean or two standard deviations from the mean or three. We're dealing like, what if it's like 1.3 standard deviations from the mean? So a couple of things that you need to remember is that the normal distribution is that bell-shaped curve. And it's important um, that you label it a normal distribution with that n. It's important that you put the mean as the first parameter with a parenthesis, then the mean, and then you put the standard deviation number, because that signifies to a reader what the heck you're even talking about. You know that the mean is right there in the middle, right? So it splits it right in half. Pretend that that splits it right in half. I'm going to erase that. So the mean splits it in half. So 50%, if it is on this side of the mean, 50% of the data is on that side of the mean. So when we're doing this, you're going to use this Desmos calculator. You can see it up here. So you're going to need to know desmos.com/calculator. So back when your parents were maybe in school, they had to look it up in tables in the back of a book or something like that, but you guys are going to use a calculator. So it's this kind of a question right here. So study is found that the mean yearly migration distance for the green turtle is 2,400 kilometers, and the standard deviation is 525 kilometers. Additionally, the study found that the migration distance of the turtle were approximately a normal distribution. So some of the things that are really important on this, you know that the mean is 2,400 kilometers. You know that the standard deviation is 525 kilometers. And they also tell you it's a normal distribution. Those are the three things that you really need to know. Oh, I'm going to use the normal distribution. Find the probability that a randomly selected green turtle has a migration distance of less than 1,800 kilometers, between 1,900 and 2,500 kilometers, and then greater than 2,200 kilometers. So I'm going to try to highlight these in the best I can. But what you have is you have a normal distribution. Okay, so you have a normal distribution where if I were going to label this thing, I know I have a normal distribution. That tells me it's a normal distribution. The mean is 2,400 kilometers. And the standard deviation is 525. If you don't have that listed on, like, let's say it's a test or something like that, and you had to turn in your notes, you wouldn't get any credit. I don't know what it is if you don't put that description up there. N, parenthesis, mean, comma, standard deviation. Now you do some of the work down here. You know that this is 2,400. Now, what we can do is we can use a calculator to kind of figure out what's happening here. We know that if we're dealing with part A, so let's say I do part A in pink. Okay, so I'm going to do part A in pink. If I do part A in pink, I know that 1,800 is somewhere down here. Now, this is 1,800. I know it's somewhere down there. I don't know how far down. But I know it's to that side of the mean because it's smaller than mean. And if I'm doing less than 1,800, I'm looking for that space right there. Well, I'm going to get a calculator to do it because that's not a set standard deviation away from the mean. So here's what I'm going to do. I'm going to go over to this. Here's my Desmos calculator. There's a little keypad down here. If I click that keypad, and I go over to functions. Notice you see this DIST. That stands for distribution. You got trig, you got stats, you got distribution, you got miscellaneous. we're going to click distribution because we're talking about a normal distribution. Distributions that you have a binomial distribution, you have a normal distribution. If I click normal distribution, now what I get is I get all this information right here. So here's what I'm going to do. I'm going to hide the keypad and I'm just going to type it using my keyboard. I know that my mean is 2400. That's the first thing that I have to type in. I know that my standard deviation is 525, and it even tells you what you need to put in there. Now it looks like this is a flat line. It doesn't look like a normal curve. This little button right here says zoom fit. If I click on that zoom fit, it'll adjust my window so that it looks like a normal distribution. Now it looks like a normal distribution. Notice that the mean is right there in the middle, 2400. It even gives you 2400 and it gives you a top value right there. Now, we're finding a cumulative distribution. So we want to find, we want to find, notice that we're going to Desmos Calculator and we're typing this in, and then we did zoom fit. I'm going to do that in a different color. Notice we did zoom fit to see the curve. And then the next thing we're going to do is find cumulative probability, okay? And sometimes that's called a cumulative distribution function. CDF is what that might be called if you take a stats class, okay? So as soon as I click on that, what I'll get is I'll get a range of values. Notice that if you use negative infinity to infinity, the range of values is everything and the probability is 1. That makes sense because everything is under this curve. Well, if I make the max 1800, notice that it does exactly what I thought it would do. It highlights that part that's 1800. Right there, highlights 1800 and further down. And notice that gives me this value up here of 0.1265. So if I type that in, 0.1265. So right around 12% of these turtles will migrate less than 1,800 kilometers. Okay, so now let's do the next part. Let's highlight the next part in green. Okay, so if I highlight the next part in green, now I'm going to go between 1,900 and 2,500 kilometers. I don't have to do anything else. I already have the normal distribution in there. But if I highlight between 1,900 and 2,500, if you think about what that would look like over here, it might look something like this. 1,900 might be somewhere right here. 2,500 is just to that side of it. And we're talking about this space in here. So we might be talking about this grouping in here when we graph it. And I'll show you what the Desmos will do that for you, but here's what you got. So you go over here and you do 1,900 for the minimum. Notice I had a maximum of 1,800, and it's like, well, that doesn't make any sense. So let's put the maximum they want in there, 2,500. As soon as I do that, it highlights the same kind of thing that I had. There's my highlight. And it tells me that percentage right there, 0.405. So right around 40% of the turtles are going to migrate in that range. That would be really important if you were a biologist and you were studying, where do I need to find these turtles? Where do I need to kind of locate these turtles? That would be what I would need to know. I could find 40% of them within that range of space, and I might want to know that. So I can figure out what maybe is causing this. I can do lots of different studies with it. The last thing is greater than 2,200. Same thing here, But now we're going to go greater than. And I'll show you what I would do on this. So let me highlight this one, and I'm going to highlight this one in, I guess I'll highlight it in blue. So greater than 2200. So if you think of 2200, 2200 might be something right around here, and greater than 2200 would be all of this, right? I mean, we're talking about all of this range up here. Anything bigger than 2200 would be this space in here. And I know I'm overcutting the green, but we already dealt with the green, so we're highlighting that. So here we go, over here we go, okay, well, our minimum is 2200. Now it'd be nice if we could put infinity in here. So instead of, we can't really put infinity, but we'd certainly like to go up past 5,000. Well, maybe if I put 10,000. That's going to get me everything. Because remember, there's so little out here that even if I put 100,000, it doesn't change my number very much. It really doesn't change it at all to all these decimal places. So there's my value. About 64% of the green turtles go out past that. So if I write that in there, 0.64838. So right around 65% migrate more than 2,200 kilometers. That's enough to get you into the that's enough of an example to get you into the rest of the Desmos. But let me do another example if you wanted to know something. So I'll do example 3 and then I'll go back to example 2. And then you guys can do whatever you want with those examples. Keep on watching if you're kind of like, well, I'd like to see another example. If you're ready to go, just go out. The average number of acres burned in the National Forest in large New Mexico County is 4,300 acres with a standard deviation of 750 acres. What the distribution is normal? What is the probability that we're between 2,500 and 4,200 acres? So, key things on this. You got a mean. So that's the average. You got a standard deviation, and they told you it's normal. So we know we need to use this normal distribution. So we know we have a situation where we have a normal curve that looks like this. We know it's normal. We know our mean is 4,300. And we know our standard deviation is 750. So that's the key. That's kind of a key thing. So on our graph here, we know this is 4,300. Now we're trying to figure out what's the probability that we're going to be between 2,500 and 4,200. Well, if I were to kind of highlight where that is, I might, and I'll do it in green. If I'm going to be between these two, if I'm trying to find that probability, I know that 4,200 might be just to the left of that, for that mean. So that's 4,200 and down to 2,500. And I don't really know where that is, but I just know that that's kind of the area that I'm looking at. I'm looking at that space right there. So I can get Desmos to do that again for me. I still have the normal distribution up here, so I'll leave it up there. But I'm going to go up here and I'm going to change the mean. I'm going to change the mean to be 4,300. So I'm going to get rid of this 2,400. And I'm going to change the standard deviation to 750. And I'm going to go over here and I'm going to zoom fit it again so I see it in my picture here. So if I go there, zoom fit, puts it in there for me. Now, I got this cumulative distribution. I know that in my problem, I'm going from 2,500 to 4,200. So if I go down here and I do 2,500, and I'm going to go up to 4,200, and you see that, it's roughly the same thing that I colored in. My curve looks a little bit not as steep, but it's the same kind of thing. So what's that probability? That probability is what I got in there, and that's 0.43867. So right around 43.88%. If I did it as a 2 decimals and I wrote it as a percentage. That's how much of the percentage that is going to burn each year. Why would I want to know that? Well, I might need to know, what do I need to do to mitigate that? What do I need to do to expect that? How many firefighters do I need to have on hand to combat that? What is my response going to be? And I need to know all that so that I can plan for the catastrophic events. If we look at like the Texas thing and the flooding, and maybe I could pull something up on it, and the cold weather, I'm guessing that doesn't happen very often. You know, the average temperature in Texas is something in December is something like this. That means way over here we might have that Texas experienced those temperatures. It might not happen very often, so they didn't plan for it. So they really struggled with it, with their response. And maybe I'll pull something up on that, and we'll do a problem on that for like the test. Take something like the Edwards Theater chain in this one. So you can keep on going. We can do this one too. You look at this one and it says, you know, here we are with a mean of $4.11, standard deviation of 1.3. We know it's normally distributed. Perfect. We know we can draw a normal curve. We know our normal curve is going to look like this. We know it's a normal. $4.11 is how much we spend, and it varies by $1.37. So maybe somebody wants to know, how much do I need to stock? You know, depending on a day. What percentage of the customers will spend less than $3? So we want to know, what's the percentage that the customers will be less than $3. So I might ask the question that way. Okay, so here I go, $4.11. That's my mean. So $3 might be back here somewhere. I need to know what percentage is going to be less than that. So I'm looking at this tail over here. I'm going to go to my normal curve again and do the same thing. I need to change the values up here, and I'm clearly not going to see it in here because I went down with different values. $4.11 and a standard deviation of 1.37. And clearly my thing doesn't work with that. So I'm going to zoom fit it. And my cumulative doesn't make any sense with this. So I might do something like this. And so notice that it kind of goes below 0. That doesn't make any sense. But to get that tail, we're going to put in negative $10. Just because I need to get that tail. I need to get the end of this tail. It may not make any sense to go less than $0, but maybe somebody brings a coupon in. You know, that's how you can maybe spend less than, where you have to give some stuff away as a group. But if we put a top end of 3, you might go in there. You might say, wait a minute, that doesn't make any sense. You know, $0. Well, you can't spend $0. Well, what if somebody comes in and has a free popcorn? Well, you're essentially giving that away, so your concessions is actually losing money. So that would explain where that tail comes in. Not very many people are doing it, but that would explain where that tail comes in. So what do we get for an answer? We get let me erase that, get rid off of my highlighter, and go green on, or I'll go blue on that again. So we get 0.2089, or roughly 20.89% will spend less than $3. So you know that, you know, this is 20.89%. So that means this grouping up here is 100% minus 20.89%. If I did that on a calculator, I'd know that the top end there is 79.11% spend more than $3. Well, that might be important to know. How much cash do I need to have on hand? How much how much concessions do I need to have on hand? Maybe I know this for one time of the day, and I need to know, well, what I'm running this movie theater, and I got to figure out how do I staff it so that I can meet the demand of this. Maybe you're in corporate office and you're trying to figure out, well, how do I need to budget for this? When do I need to deliver the concessions? So there can be a lot that go into this if you expand on it a little bit. If you have any questions, let me know. Hopefully this made sense. Hopefully you understood it, and hopefully you kind of liked it a little bit, because if you go into business, you're going to have to do some stuff on this. Good luck.